All right, welcome back, folks. We are still in section 5-4. This is video number 5. All right, where we left off, we were talking about the hypergeometric distribution, and I said this is the formula. Kind of a awkward looking formula. However, I believe we will sort our way through it by using an example. So here's the example that the author gives us. This is assistant manager applicants. So 10 people apply for a job as assistant manager. 5 have completed college, 5 have not. Okay, so far so good, right? There's 2 outcomes. They're either a college graduate or they're not a college graduate. If the manager selects 3 applicants at random, find the probability that all 3 are college graduates. Okay, so A is the 5 college graduates. B is 5 non-graduates. So A and B, those are the 2 numbers that we were talking about before. But he also uses A and B to talk about a type. So the type A and type B is the college graduates and the non-graduates. There's N is equal to 3 because he's choosing 3 college graduates. Okay, he wants to know what's the probability that all 3 are college graduates. Okay, and I believe I may have misspoke there. So let me just fix that rather than trying to fix the tape. Let me just say it properly. It's unfortunate he's using 3 for the number of for the sample size, and he's using 3 for the number of successes. So it's a little bit awkward. It gets confusing. Okay, so it's selecting without replacement a sample of size n with X items of type A. So that means the sample of size n, the size n is selecting 3 applicants out of the 10. Okay, so he's selecting 3 applicants out of the 10, and X is saying that they are college graduates. So that's this business right here, X items of type A. So it's 3 applicants of type A being the college graduates, and N minus X, that would be 10 subtract 3 that are not college graduates. Okay, so that's where the N subtract X comes in of type B. So what you've got to do is you've got to write this out for yourself and make that comparison going from the problem to the definition, and it will make it more clear to you if you write it out yourself. Okay, so we've got type A, there's 5 of them, type B, there's 5 of them. We select 3, and we want to know what's the probability of that X, in other words, 3 of the 3 that we've chosen, what's the probability that it will be college graduate? Okay. All right, so it's a little bit awkward. I wish he would have picked different numbers, but it is what it is. Okay, so we plug it into the formula. Now, I wish he would write down the formula, but he didn't, so here we go. So the probability of X, of getting 3 college graduates, so there's the P of X. Let me see if I can make this a little bit wider to get everything in there. Give me 1 second. Okay, I made the size of the book a little bit smaller. Hopefully you can still read this, but you got your own book, so you should be following along. Okay. All right, so let's bounce back and forth between down here and up here. Okay, so the probability of X successes, in other words, getting 3 of the probability that all 3 are college graduates out of the 10 people that applied for the job. Okay, you understand the scenario. I want 3 college graduates out of the 10. Well, if 3 of them are college graduates, then that's 5 choose 3 are college graduates, right? Because 5 of them are college graduates, and I'm choosing 3 out of the 5. Over here, we have non-college graduates. So if 3 out of the 3 applicants are college graduates, that means that 0 of the 5 non-college applicants are chosen. I hate this problem because the numbers can kind of get in your way. But do you see what's going on here? He's selecting 3 applicants, and he wants to know if all 3 of them are college graduates. Well, if all 3 of them are college graduates, that means that 0 are not college graduates. So that's 0 out of the 5. So the numerator is very straightforward. It's just, you pick 3 out of the 5 and you pick 0 out of the 5. Calculate those numbers, multiply them out, and you get 10. On the bottom, that's always the same. That is the number of successes or the number of occurrences, I should say, is the number of occurrences in the sample space. So there's 10 people that were chosen, 10 people that applied. So 10 people apply, and he selects 3 of them. He selected 3 applicants. So it's 10 choose 3. So that works out to be 120. So the probability is 10 over the 120, and that's 1/12, or that's another way of saying that in decimal format, 0.083. I don't like that problem, not because, the only reason I don't like that problem is because the numbers get in your way. Let's see if we can do this one a little bit easier here. Okay, 2 out of every 10 houses have 0 insurance, no insurance. 5 houses are selected from 10 houses. Find the probability that exactly 1 will be uninsured. So probability of X is 1. So probability of X being 1 is equal to, okay, so the 2 categories, A and B, the 2 categories are insurance or not insurance. Okay, so A is equal to 2. So the no insurance is A. The B is they do have insurance. So if 2 of them are uninsured, 8 of them do have insurance. Okay, N is 5. Now the reason N is 5 is because we're selecting 5 houses from this group. Okay, find the probability that exactly 1 will be uninsured. So probability of 1, okay, so it's using this formula up here. You got to bounce back and forth of choosing X out of the A and then N minus X out of the B. So X out of the A, that's 1 out of the 2. So 2 of them are uninsured. So what's the probability, or how many ways can you pick 1 out of the 2? 8 of them are insured. So what is the number of ways you can pick 4 out of the 8? How many ways can you do that? So that's what these 2 numbers represent. So you apply the formula, multiply it out, that's what you get. On the bottom, the numerator is always the same. The numerator is always the number of occurrences in the sample space. Well, there's 10 houses chosen, or I shouldn't say chosen. There's 10 houses are in the sample space, and you've chosen 5 of them. So it's 10 choose 5. So 10 choose 5 is 252. So multiply all this out, and this is the number that you get. Okay. Man, that's complicated, isn't it? That's one of the most complicated formulas that we've used. All right, so it's so important on this kind of a problem to write everything out, write out the formula, make sure you know what is my A, what is my B. And it's not as hard as it looks, though, because it's always going to be the same thing. You're picking X successes out of type A, and the rest of them, is a dichotomy here. They're either a success or they're not. So if X are successful, N minus X are unsuccessful. So it's N minus X out of the other type. So we talked about insurance versus not insurance. We've talked about college graduates versus not college graduates. It's always something like that. It's a dichotomy. It's one or the other. It's a binary type situation. So on the top, you're always picking some number of successes out of the first group and some number of successes out of the second group. You're choosing those. How many ways can you do it? You multiply them. That gives you the number of ways that you can get whatever it is that you're looking for. And then in the denominator, it's always the same thing. How many successes can you have in your sample space? So if you're choosing a sample of size N out of the entire group, well, the entire group is A plus B. It's a dichotomy. It's only 2 different types of groups. So if you have A of one and B of the other, add them up. That tells you how many you have altogether. You're choosing N out of that entire group. So the formula is not quite as bad as it looks like. You just got to do a few problems. I'm going to do one more problem here, okay? I got lots of time. You have 12 compressor tanks. Oh, here's his explanation. Why are we doing this? You know, we take a sample and we test the sample and we move on from there. So I'll let you read that on your own. So you got 12. We have 12 compressor tanks are checked, okay? Okay, so I'll tell you what, I'll let you read this. You can always pause the video. All right, so then I did this one in my lecture notes. Let me bounce over to my lecture notes. I think I have enough details in there that'll hopefully make it a little more clear, okay? And then you can be looking in your book and compare what I wrote in my handwritten notes to what he wrote here, and hopefully that'll be of some benefit to you. So let me bounce. Give me 1 second here. Okay, so this is the example, example 5-33, page 295. All right, we're looking at a lot of 12 tanks. In other words, we just grabbed 12 tanks. So 3 tanks are checked for leaks. All right, so since we're checking 3 tanks, we're picking 3 out of the 12. That symbol means therefore. So N is 3. The problem says that if 1 or more have a leak, the lot is rejected. So if you, out of these 12, if you have 1 or more that has a leak, you're going to reject the entire lot. Okay, let me bounce back here to hopefully this will make it a little more clear here. When you manufacture something and you ship them out, usually what will happen is the quality control guys will select a few items, they'll test them, and based on those few items, then they'll decide whether they refuse the entire shipment. So, you know, you don't want to test every single item. So realistically, it'd be a little more realistic if you said there was a lot of 500 tanks and we checked 5 of them or something like that. But here he's saying, well, there's only 12 tanks that we are checking. Okay, we look at those 12 and we check them for leaks. So his language is a little awkward here. I don't like his language, but that's the basic idea. The basic idea is you have 12 tanks. You're going to select 3 of them to test them. You don't want to test all 12. You check 3 of them, and if one or more of them, one or more of the 3 has a leak, then we reject the entire lot of all 12. Okay, so now the question is, find the probability that this lot is going to be rejected. But here's what you know. This is kind of weird. You know that there really are, in actual true fact, there are actually 3 defective tanks in the lot, in these 12, okay? All right, so that is a little bit awkward there. So I'm going to stop this tape, and I'm going to, on the next tape, I'm going to go through this with my handwritten notes.